Welcome to aminacademy.com. In mathematics, let us discuss about history and mystery of pi. For thousands of years, mathematicians have attempted to extend their understanding of pi, sometimes by computing its value to a high degree of accuracy. Ancient civilization, including Egyptian and Babylonians, require a fairly accurate approximation of pi for practical computation. Around 250 BC, the Greek mathematician Archimedes created an algorithm to approximate pi with arbitrary accuracy. In 5th century AD, Chinese mathematicians approximated pi to 7 digits, while Indian mathematicians made a five-digit approximation, both using geometrical techniques. The first computational formula for pi based on infinite series was discovered a millennium later. Earliest known use of the Greek letter pi to represent the ratio of circle's circumference to its diameter was by the Welsh mathematician William Jones. The invention of calculus soon led to the calculation of hundreds of digits of pi, enough for all practical specific scientific computations. Nevertheless, in 20th and 21st centuries, mathematicians and computer scientists have pursued new approaches that, when combined with increasing computational power, extended in the decimal representation of pi to many trillionth of digits. These computations are motivated by the development of efficient algorithms to calculate numeric series, as well as the human quest to break records. The extensive computations involving have also been used to test a pi, a number which is mystery, have a lot of mysteries, as well as it's a endless and non-repetitional number. Pi, the ratio between the circumference and diameter of a circle, is perhaps one of the most famous number on all of the mathematics. It is irrational, transcendental, and never ending. Look at this figure here. The ratio, the basic definition of the pi is the ratio between the circumference of the circle to the diameter. This size may be any big or small circle. This ratio is constant. That is called pi. The concept of pi is ancient. It's been known to humanity for at least 4,000 years. In 2000 BCE, Babylonian mathematicians performed the first known calculation of the area of a circle using the circumference of an inscribed hexagon and derived an approximate value of pi of 3.125. In 1600, pi had been calculated up to 35 digits using the method of inscribed polygons, although with little theoretical progress made beyond Archimedes' work. In the 17th century, however, new analytical techniques were developed in the field of mathematics, which allowed for improved calculation of pi using infinite series. Some famous mathematician for finding the value of pi. The great Indian mathematician Aryabhatta calculated the pi value up to 3.1416. Here, this is a fascinating series for that is infinite series for Madhava series is known to be Madhava series. We can calculate the pi value by using this series, expanding this series, and put the value of n from 0 to infinity. We can get a lot of continuous, that is endless number. You can get it from this series. So here, whatever the series, whatever the finding is a only approximate of the value of the pi. Here Archimedes finding the value of pi like. Here, look at this figure. It is a square. Is side as root pi value and radius is 1. It seems to be like. Here pi is in between the ratios of two numbers, that is 2 to 3 over 71 and lesser to 22 by 7, somebody found. That is also useful result. Here Euler did this pi value like this. Here sigma and 1 to infinity 1 over n square equal to pi square over 6. If we expand this series, it gives the pi square over 6 values, and we can get from that expansion we can get the value of pi in any approximation. Eventually, though, in the early 20th century, the Indian mathematician Srinivasa Ramanujan developed an incredibly efficient formula for calculating pi based on its reciprocal fraction, which was later incorporated into computer algorithms. Here is that is reciprocal series, that is 1 over pi is equal to 2 root 2 over 9801, that is a constant, into sigma n equals 0 to infinity 4n factorial into 1103 plus 26390 n over n factorial over 4 into 396 power 4n. So by using this value, this he is getting approximately the value of pi is 9801 over 1103 over into square root of 8. Now that pi is continued fraction value can be written as like here 3 and plus 1 squared over 6 plus 3 squared over 5 squared over this, all it's continued. Also you can get the pi value in continued fraction. Deceptively simply, pi is the ratio of the circumference of a circle to its diameter. We know that. The miraculous fact about pi is that no matter the size of the circle, the value does not change, making pi as a mathematical constant. Adding to its allure, pi is also an irrational number, which means that its decimal representation has no end and no repeating pattern. For example, pi is expanded continually and decimal, then we can get any set of numbers. What you think means any set of numbers, like suppose your birthday, even your birthday can fix that number fashion fixed in the pi values. Suppose y is 3.142, it is continued at any stage, maybe millionth stage, any stage, you can get your own number. Like suppose your birthday is something numbers or 6-digit number, you can fix that number in that continued decimal places. We can get it anywhere else. It's a very interesting fact. Euler did it like the infinite series, like sigma n equal to 1 to infinity 1 over n square equal to pi square over 6. From using n as 1 to infinity, we can get the pi values here also. There is even a holiday dedicated to pi, approximately known as Pi Day, which is observed annually March 14th in every day, that is 3 over 14, right? Next came the Gregory-Leibniz series, which made use of both infinite series and trigonometric functions to develop formulae for value of pi divided by 4 and 6. By the end of the 18th century, over the 100 digit of pi had been calculated using this method, and others derived from it. That means the Gregory-Leibniz series also useful for finding the value of pi to some approximations. The subsequent development of more about advanced computers mean that pi calculated be to higher and higher decimal place. By 1949, the ENIAC computer could calculate 2037 digits of pi, and the IBM 704 was able to calculate pi value as 16,167 digits a decade later. The IBM 7090 broke the million digit mark in 1961, and CDC 7600 computer was able to reach pi's values as millionth decimal places in 1973. Since that pi, the finding the value of pi for more approximation, still development is going on. In mathematics, Leibniz formula for pi, named after Gottfried Wilhelm Leibniz, states that, suppose here pi by 4 value here, pi by 4 value is easily expressed as 1 minus 13 plus 15 minus 17 plus 19 minus 21 plus 23 like. So if you extend this series, the approximate value of pi by 4 we can get. Therefore, very easy way to find the value of pi is here, that is 4 times 1 minus 13 plus 15 minus 17 plus 19 minus 21 plus 23. That is alternatively changing, like if you find addition, subtraction, the sum of these values multiplied by 4 gives approximate value of pi. Still more discussion we can do about pi. For timing, it's enough, and somewhat interesting about pi we have done. Please subscribe our YouTube channel.